Dr. Rajeshwar Mathur. In the present day environment, we encourage students to engage in home activities. I am designing simple activities with my teenage grandchildren which are entertaining, creative and instructive. This video has three components, namely studying the reflection of light, finding the fastest path between 2 points, and combining our ideas to come out with the famous Fermat's principle of light.
Hi, my name is Ria and I'm a rising freshman in high school. The purpose of this video is to learn about the reflection of light. I have created an innovative experiment to study and further my knowledge on reflection. Okay, so basically for the project, we want to know that when light hits a mirror, where does it go after reflecting? Does it go in a fixed direction or does it go in any other direction? So for the project, we used a plain mirror. The mirror we used was in our bathroom. We have a step stool that we used for an elevated service, a coloring pad, and a protractor. So the normal line is at 90 degrees. The angle we chose was at 50 degrees. If you look through the mirror, the image appears to be at the back of the mirror. However, the light doesn't go through the mirror, it reflects back and bounces off the mirror. If we take the toothpick and align it with the image shown, that gives us the direction of reflection. Okay, so between the normal and the incident ray is 40 degrees. That's the angle of incidence. And between the normal and the reflected ray is also 40 degrees, which is the angle of reflection. If you take the toothpick and put it up or below, you can't align it properly, so it has to be on the same plane. So from this we can conclude that the normal, the incident ray, and the reflected ray are of special interest if the angle of incidence is 0 and we place the toothpick along the normal. We see that the image is among the same line. And try the same thing with any other angle. In our case, we used 50 degrees. You can use 40, 60, any angle would work for this, and you come to the same conclusion.
Hi, I'm Atin.
Hi, I'm Amol.
We're 8th graders. We are working on a problem which involves getting a hungry bird to its food the fastest. The bird is sitting on a 20-foot tall tree. There is a 40-foot long ground, and on top of that, there's a 5-foot tall fence. The bird wants to get the food and then go sit on the fence. As you can see, the bird can take many paths, but the bird wants to take the fastest path. There are infinite paths, so how do we find the shortest? Of course, the shortest path would be a straight line from the tree to the fence. But you have to remember the bird wants to get the food and then go sit on the fence. You could measure all the lengths with the ruler, but there are so many.
I can make a suggestion. In the sport cricket, the pitch is about 20 meters long. And a good length ball is pitched 5 meters from the stumps. This is about 3/4 down the pitch. You can apply the same concept to this problem. So I think we should start measuring from the 30 feet mark, which is also 3/4 down the 40 feet ground.
I've measured some of the lines around 30-foot mark, and I've measured that the green line, which goes to 32 feet mark, is the shortest.
Okay, so I tried the problem, but instead of graphing, I made an equation and then I put the equation in my graphing calculator. So we can let the point where the bird flies to be x, and then the remaining distance on the ground be 40 minus x. And we're trying to find out the distance of this line and then this line, because that's going to be the bird's flight path. So for this question, I used the Pythagorean theorem, which is a squared plus b squared equals c squared, or c is the square root of a squared plus b squared. For the Pythagorean theorem to work, you have to be working on a triangle, and the triangle needs to be a right triangle as well. So for this triangle, it'd be 20 squared plus x squared is equal to this, is going to be equal to the square root of this. And then for this one, it's going to be 5 squared plus 40 minus x squared. And then the square root of that is going to be this line. So this is the equation that you get at the end. And then I put the equation into my graphing calculator. And I got that x is about 32 feet when the bird hits the ground. So as you can see, x is 32, and I think got this as well. So now we know that the spot that the bird should fly to get the fastest flight path is going to be at 32 feet.
Let us now assume that instead of the bird, we have a source of light here. The ground is reflecting like a plane mirror, and we put a detector of light here. So the light comes from here, this point, gets reflected and arrives at this point. Which of these paths will the light choose?
The light will choose the path for which the angle of incidence is equal to the angle of reflection.
Let me measure some of them. For the blue line, the angle of incidence is not equal to the angle of reflection. For the green line, yes, the angle of incidence is equal to the angle of reflection.
So we can conclude that when going from one point to another point, the path that's chosen by the light is going to be the shortest and the fastest.
This is the famous Fermat's principle of light.